Welcome everyone, I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy, Muradnagar. This is the lecture number 13 and it is the continuation part probability. So, it is part of 3 of probability and the subject is biostatics and research methodology. The subject code is BP 801T and the course is Bachelor in Pharmacy and university is Dr. APJ Abdul Kalam Technical University. In this lecture, I will tell you about the population, sample, that means what is population, what is sample and the large samples, small samples, null hypothesis, alternate hypothesis, type 1 error, type 2 error and standard error of mean. So, the first term is population. In statistics, population is well defined group which is being studied. So, population is the well defined of subjects on which we do study, okay? And the small part of this selected population is known as sample. So, if we have like here is this side, these are the, if this is the population and if we select 4 person from this, so this is called sample and this is the population. The population in statistics is a well defined group which is being studied and sample is the small part of the population. Sample is a small part of population, okay? And as sample are 2 types, large sample and small samples, there is no particular definition to define the small sample or large sample, but in general if the sample size is less than or equal to 30, we consider a small sample and if it is more than this or more than 30, then we consider large samples. Now, we read null hypothesis. Before going to read null hypothesis, first we read hypothesis. What is hypothesis? Hypothesis is a hypothetical statement about our study. When we go in the research and we have some objectives and we hypothesized some objectives, these hypothetical statement are called hypothesis. And hypotheses are 2 types, null hypothesis and alternate hypothesis. The null hypothesis, it is the statement regarding the value or values of unknown parameters. Typically, will imply no association between explanatory and response variable in our application. So, in null hypothesis, it will always contain an equality. That means, we consider in null hypothesis there is no difference between the explanatory variable or response variable, there is no association. This is a hypothetical statement about our study we want to reject at the end of our study. In the simple terms, we say null hypothesis is a statement which we want to reject at the end of a study. Okay. So, in null hypothesis, we take there is no significant difference between the population mean and the sample mean, and if we have 2 sample study, then we consider there is no difference between the 2 sample means, or we can say the both are equal. So, we also say null hypothesis is a negation statement. So, why we take no difference or negative statement or no association between explanatory variable and response variable in null hypothesis. To explain this, why we take no difference. To explain this, we take an example. For example, in we have a research question, all crows are black. The research question is all crows are black. So, how do we test this? The null hypothesis for this research question is all crows are not black. So, to test this, we have टू मेथड कि हम एक तो जो है अपने लिमिटेड टाइम जो हमारे रिसर्च को का है उसमें ब्लैक क्रो को सर्च करें, लेकिन उसमें क्या होगा, सपोज टाइम पीरियड 2 ईयर्स है तो 2 ईयर्स में कुछ क्रोज जो हैं बाहर चले जाएंगे, तो वो हम उन्हें देख नहीं पाएंगे कि वो ब्लैक है या वाइट है या कोई और कलर में है, या कुछ हमारे बाहर से वापस आ जाएंगे, उस पीरियड में बाहर से आए हुए होंगे. तो it is a very typical job, but the another best smart way is we take null hypothesis that all crows are not black, or we consider that all crows are white. The null hypothesis we consider all crows are white. तो उस केस में हम क्या करेंगे, हमने क्या करा कि हमने एक पर्टिकुलर टाइम पीरियड में पूरे 2 साल तक वाइट क्रो को सर्च किया, और जब 2 साल के बाद वाइट क्रो नहीं मिला तो हमने कह दिया ऑल क्रोज आर ब्लैक. सो इट इज वेरी इजी टू डिस्प्रूव देन प्रूव, एज इट इज वेरी इजी टू डिस्प्रूव देन प्रूव. सो वी टेक इन नल हाइपोथेसिस देयर इज नो डिफरेंस, because as I had already tell you that the null hypothesis is the statement which we want to reject at the end of study. Okay? So, null hypothesis is a statement which we want to reject at the end of study. And it is very easy to disprove than prove. So, we take no difference in null hypothesis. And second is alternate hypothesis. Alternate hypothesis is the statement contradictory to the null hypothesis, and it will always contain an inequality, because in null hypothesis there is a equality, that means both means are equal, or we say there is no difference between two means. So, in alternate hypothesis it is the containary statement of null hypothesis, and it will always contain an equality. This is a hypothetical statement of our study which we want to accept at the end of study, and there is a significant difference between the sample mean and population mean. Now, hypothesis testing, this is very important table. Hypothesis testing, in test results in true state null hypothesis true and null hypothesis false. There are two conditions in true state, null hypothesis true and null hypothesis false, and these are the test result, null hypothesis true and null hypothesis is false. So, first case, when in true state null hypothesis true and test result shows the null hypothesis true, this is a correct decision, while if in true state null hypothesis is true, but test result shows null hypothesis is false, this is called type 2 error or type 1 error or alpha error. When true state null hypothesis true, but test result shows false, this is called type 1 error or alpha error. Second, in true state the null hypothesis is false and test result shows null hypothesis true. In true state null hypothesis is false, but test result shows null hypothesis true. So, this is called type 2 error or beta error. And the fourth case is when null hypothesis false and test result shows false, this is the correct decision. So, in the testing of hypothesis, these are the main two type of error. Type 1 error, when null hypothesis is in true state, null hypothesis is true and test result shows null hypothesis false, this is called type 1 error or alpha error. And if in true state null hypothesis is false, but test result shows null hypothesis true, this is called type 2 error or beta error. Alpha is the probability of type 1 error and beta is the probability of type 2 error. Our goal is during the study that the alpha and beta reasonably small. In general condition, we take alpha equal to 5% and beta equal to 80%, and it will change from study to study, but generally we take alpha equal to 5% and beta equal to 20%. Sorry, it. Now, example of efficacy of test for new drug. In the testing of hypothesis, we have different steps to test a hypothesis, and I will explain all the steps with this example. We want to test a efficacy of a new drug. So, for this a drug company has new drug and wishes to compare it with current standard treatment. Federal regulators tell company that they must demonstrate that new drug is better than current treatment to receive approval. So, for this the firm runs clinical trial where some patient receive a new drug and other receive a standard treatment. That means, they make a two group of subjects, and for one group during the clinical trial they give the new drug, and for the second group they give a standard treatment, and the variable is the response of the therapeutic effect is obtained, and they collect the therapeutic effect of the treatment, and they assume that if the scores are higher, then the treatment is better. So, in this example, the parameter of interest is mean of new drug and mean of standard treatment, and we want to test is there significant difference between these two treatment or not. That means, is mean of new treatment equal to the mean of standard treatment, we want to test. So, when we testing the hypothesis, the first step is we first write the null hypothesis. The first step is state the null hypothesis, and in this example the null hypothesis is that new drug is no better than standard treatment. As we know, in the null hypothesis we take there is no difference between the existing treatment and the standard treatment, or existing treatment and new treatment. So, null hypothesis H naught such that mu new minus mu standard is less than or equal to 0, because in this example we want to test is new drug is better than standard or existing treatment, and the assumption is the treatment which have high score is better. So, if mu new minus mu standard is less than or equal to 0, or we can say the mean of new treatment minus mean of standard treatment equal to 0, or you can say mu new equal to mu standard, or mean of new treatment equal to mean of standard, and the alternate hypothesis is the just opposite to the null hypothesis. So, in alternative hypothesis we write new drug is better than standard treatment. That means, mean of new is greater than the mean of standard. So, H A such that mean of new minus mean of standard is greater than 0, and the sum are experimental sample data. For this example, y bar new is the mean of new treatment score, y bar STD is the mean of standard treatment score, S new is the standard deviation of new treatment, and S STD is the standard deviation of the standard treatment. N new is the number of subjects or number of patient, or you can say size of sample of new treatment group, and N standard is the number of sample or number of subjects in the standard treatment group. And it is not necessary that कि ये दोनों इक्वल हो, ऐसा कोई जरूरी नहीं है, दोनों अलग अलग भी हो सकते हैं. Now, in the third point, so first we state during the testing of hypothesis, we first state null hypothesis, second alternate hypothesis, and third is level of type 1 error. The type 1 error concluding that the new drug is better than the standard, when in fact it is no better, H naught ineffective drug is deemed better. Type 1 error we consider in this example concluding that the new drug is better than the standard, that is H A, when in fact it is no better, null hypothesis. Inactive drug is deemed better. Traditionally, alpha equal to probability of type 1 error, and it will be equal to 0.05, and type 2 error is failing to conclude that the new drug is better, that is alternate hypothesis, when in fact it is effective drug is deemed to be no better. So, traditionally a clinically important difference D is assigned and sample size chosen, so that. So, beta is the probability of type 2 error, and this is equal to or less than 0.2, 20%. And the next step is test statistic. Test statistic is difference between the sample mean selected to the number of standard deviation or standard error from the null difference 0 for the population mean. So, test statistic we apply z equal to y 1 bar minus y 2 bar square root of s 1 square upon n 1 plus s 2 square upon n 2, and we calculate the value of z. And the last step in null hypothesis testing is rejection region. In this, if our calculated value of z or any test, if we apply t test or z test or f test, and if the calculated value of z is less than the tabulated value of z, then if I repeat, if the value calculated value of z is less than the tabulated of value of z, then we say there is no significant difference and we accept the null hypothesis. And if is, or in statistical terms you can say set of values of the test statistic that are consistent with alternative hypothesis such that probability it falls in this region when H naught is true is A, that means Z observed is greater than or equal to Z alpha. So, we accept null hypothesis if the calculated value of Z is greater than the tabulated value of z. Now, the last term in our present lecture is standard error of the mean. The standard deviation of the distribution of sample means is called the standard error of mean or the standard error for short. I repeat, standard deviation of the distribution of sample means is called the standard error of the mean or standard error in short. It is represented by the following formula: standard error of mean equal to sigma upon square root of n, where sigma is the standard deviation of the population and n is the size. Since the standard deviation of the population is often unavailable, a good estimate of the standard error use the standard deviation of the samples. So, this is the newly modified formula of the standard error. It is shown as standard error of mean equal to s by root n. In the previous slide, I tell you that generally we find the standard error of mean with the help of formula sigma by root n, but sigma is the population standard deviation and it is generally not available. So, it is better to calculate the standard error of mean with the help of sample standard deviation. So, to calculate the standard error, we apply another formula s by root n, where s is the standard deviation of the samples or sample and n is the sample size. What are the importance of standard error of mean? The standard errors are important because they reflect how much sampling fluctuation a statistics will show. That means, if more fluctuation in sampling, then the standard error is very high and our data will be not normally distributed, or we can say it is not good representative of our population. So, standard error is very important and our goal is to minimize the standard error for a good data or normally distributed data. The standard deviation should be less than the 30% of the mean. So, standard deviation less than the standard deviation. The inferential statistics involved in the construction of confidence interval and significance testing are based on the standard errors. Generally, when we do the inferential statistics, we need confidence interval and the confidence interval will be calculated with the help of the standard error, and also any test statistics to test the data or to test the null hypothesis, we need standard error. So, it is very important for inferential statistics. The third importance is the standard error of statistic depends upon the sample size. As you see in the previous slide, standard error is the depends upon the sample size, and you see here the standard error of mean or standard error is inversely proportional to the square root of the sample size. It means, if the sample size is increases, standard error is decreases. So, now example, the systolic blood pressure was measured in a sample is 566 male. We have a study in which we have measured the systolic pressure for 566 male, and after the study we have found that the mean of the systolic pressure was 128 millimeter of mercury, and standard deviation is 13.05 millimeter of mercury for that study. And we want to calculate the standard error of mean for the sample. Now, the solution for this, as the mean is 128 millimeter of mercury, and standard deviation is 13.05 millimeter of mercury. Now, standard error of mean, we have formula S by root n, where S is the standard deviation, this is, and n is the sample size. Here n is the sample size 566 males. Now, put the values of these in the formula SEM S by root n. So, SEM equal to 13.05 upon square root of 566, and on solving this we get the standard error is 0.55. So, this is the standard error of this data, and you observe that the standard error is less than the standard deviation of the sample. For good study, the standard error should be minimum, and standard deviation should be 1/3 or 30% of the mean. So, this is the standard error of mean, and today we have learned 2 points: null hypothesis. Null hypothesis is a static hypothetical statement which we want to reject in our study, and in this we consider there is no significant difference between the two means, or there is no association between the explanatory and response variable. Second thing, alternate hypothesis. Alternate hypothesis is just opposite to the null hypothesis, and in this we consider there is a significant difference between the two means of variables, or there is a significant association between the response variable and explanatory variable. Third, we have read type 1 error. Type 1 error is if in true state null hypothesis true, but test result shows it is false, then this is type 1 error, and it is represented by alpha, and in standard condition the value is 0.5. The second is type 2 error. It is when null hypothesis is true, but in test result shows it is false. This is type 2 error and beta, and its value is 20%, and our goal is alpha and beta should be small. So, these 4 terms are we have read, and the steps in testing of hypothesis: first we write null hypothesis, alternate hypothesis, type 1 error, type 2 error, then we apply test statistic and the rejection region. Okay, thank you.